Welcome to the 2023 SEDA conference, in person in Glasgow and online. It's a blended event. The conference this year focuses on retrofit. It's something we've talked about very often, but it's never not relevant. And there's so many bits of information out there that it can be very confusing for people to say where to start, how can you do this well, what's the problems. It's a huge subject, and there is no easy way to learn all the ins and outs of it. But we're going to try today. We're going to give you a whole range of approaches here, from the really practical to the theoretical to the why is it happening at all and do we need to do it. And we've tried to arrange a whole series of different speakers who can give you different aspects on this. And the whole point is, when we've got all these people in the room being able to put the ideas together, that what comes out of this is maybe something that we can go, yeah, this is really good. This is how it all works together. This is how we do it well.
Thank you. Good morning, everybody. Fabric first seems to be the mantra these days, and it's a shame it wasn't 50 years ago. But Max Fordham, who sadly died last year, had this ambition. He told me about this in the 80s, and he finally did it in his own house, but unfortunately only lived in it for 2 or 3 years, which actually got the very first net zero certification last year by the UK Green Building Council. Now, how much does this sort of thinking apply to existing buildings? Sadly, Hellman, the architectural cartoonist, sort of captures it all nearly 50 years ago in this case, saying, why have we been building gas guzzlers when traditional buildings could teach us an awful lot? And we've now had nearly 50 years more gas guzzlers, unfortunately. Now, if we want to, I sometimes give a talk a bit like this called Retrofit Our Buildings or Our Brains, but I thought that was a bit, facetious for you, so I decided not to. But essentially, we may need to change the whole mindset in which we approach buildings. So on the train over here, I thought, well, actually, I wouldn't mind recapitulating just a few bullet points from how my mindset's changed about retrofit over the last half century. Because we've got a number of light bulb moments. After the energy crisis, nearly 50 years ago now, coming up, we found a lot of buildings didn't get tuned up, and there are a lot of really simple things you could do. Then I got involved in historic buildings and cathedrals and things like that and did some monitoring, and moisture came really up the scale in terms of the performance. And I also started looking at non-domestic retrofit and finding enormous differences between what the designers anticipated and what was being built and how it was performing. And also, even though sometimes you had facilities management companies coming up saying, oh yes, we know about all the energy, they hadn't even seen an energy bill.
Buildings is for comfort, and buildings, how you do that is through physics. In my mother tongue, why is 點解? How do you explain? The cavity is created for a reason. With 2 hours of rainfall, the outer leaf gets saturated. So what is happening to the cavity? It is designed to wick water, to have cavity drain, weep holes, ties that have drip tips. And if we retrofill it with anything, doesn't have to be beads, anything at all, what happens? This is taken from a retrofill website, supplier. They say, oh, it's perfectly fine. 95% of the water will actually drain down and exit anyway. What happens to the 5%? When the external leaf is saturated, the internal side of the external leaf is at 100% relative humidity, very high water vapor. Where is it going? The cavity is now no longer vented. It will eventually diffuse and go towards the inside. It's inevitable. It might take 10 years because diffusion is a very, very slow process. A sample this size takes about a week. So, it takes a long time, but that's what happens. So the manufacturer claims that it's fine, but does it really work? I have actually in my work taken out a lot of previously filled cavities. And there are reports out there that shows that it doesn't work. Of course, there are better evaporative potentials for south-facing, whatever, and it could take even longer for it to actually go through. But there are scientific calculations that supports what I'm saying here. Frustratingly, EPC makes people do it. Unless they do it, they don't get funding. Oh dear. Oh well. But what I want to impart to you in the last minute of my talk is really, can you also explain every part of your home? And I think that's where building physics is for everyone.
When you're designing a building with a blank piece of paper, things like orientation, form, and fabric, these things you can design these things on a piece of paper and essentially they can be almost free and they can have the biggest impact on what the CO2 impact of that building is going to be. And once we've nailed those things, we then think about really good mechanical and electrical services and then adding in some renewables. But of course, as we talked about, in an existing building, the orientation, the form, all that stuff is already fixed. So in my home, I got to work on the easy win fabric improvements that I could make. So these things were draft proofing around windows and doors, adding attic insulation, fixing that wonky attic hatch, and just generally getting on with all the maintenance that needed to be done over the past 100 years. So during this process of me upgrading my house, my boiler packed in after the first couple of years. And I immediately went out and I replaced my old non-condensing gas combi boiler with a brand new condensing gas boiler with some really, really nice weather compensated controls. And overnight that dropped the CO2 emissions associated with my heating system by about 15%. And I was quite happy with that. I get on with my deep retrofit plans. Now, I really love the way my house looks. That's one of the reasons that I bought it and I live there. So my deep retrofit plan was, or is, internal insulation with secondary glazing. But as soon as I start this process, something becomes incredibly clear to me. And that is just how incredibly slow the process is. It's not only incredibly slow, because I'm doing most of the work myself, it's also incredibly dirty and messy. You've got 125 years of dust and soot built up behind those walls, and the moment you touch them, it gets absolutely everywhere. It's also incredibly disruptive. You're living in a house with a family, and you're taking entire rooms out of action in one go, and organising your life around that is not trivial. And the third thing is, it is really expensive. And not just for the insulation materials, but also to redecorate afterwards, and then obviously to reinstore any sort of period features such as sort of plaster cornice that you might have damaged in the process. But I had my plan, and I was implementing my plan. I was getting on with it. I reckon I might be finished working my way around the house by about 2040, and then in 2040, perhaps I think I'm ready for some sort of alternative form of heating.
I'm Alex. As it said, I'm from the Scottish Futures Trust. If you don't know the Scottish Futures Trust, we're an organisation that advises the government, local authorities, public, private, third sector on getting better outcomes from infrastructure investment. Don't all go to sleep. infrastructure's very interesting. So I guess really my presentation is about the fact, it's recognizing the fact that the buildings that we choose to invest in now will shape the way that we live in the future and how we experience the world for the coming decades. So those choices about what we choose to retrofit or invest in are really important. So my presentation is really trying to explore how do we make the right decisions at the right stages with the right people to make sure that we don't spend our emissions envelope and our money on the wrong things, and that we build things in the right places, doing the right things that serve community now and in the future. So I'm predominantly going to be talking about the Net Zero Public Sector Building Standard, which we've developed at the Scottish Futures Trust. This is a national standard, it's voluntary, and essentially it tries to make sure that buildings are applying the highest standards of net zero throughout. So to give you a quick overview of the standard, it's made up of 6 interrelated objectives. So from 2 to 6 onwards, that's thinking about carbon costing, management, quality of the building or the product when it's finally built. And that's really from construction onwards. But what I'll be talking about today is objective 1, which is the place requirements of the standard. So this is really about making sure that we make the right decisions pre-investment. So this is about the earliest decisions that you make in your project. So the place part doesn't focus on all of that technical, complicated bit, which I won't be talking about today. It actually focuses on the need to strategically assess both your project and your estate, your whole portfolio if you have one, to make sure that you're building something that has a long-term need. And to make sure that we consider those wider considerations, so not just financial, so the social, the economic, the environmental, bringing in all those perspectives to ensure that our investment provides maximum impact to the users and therefore essentially value for money. So really the whole point of this piece of work is to make sure that when we spend money and our emissions envelope, we actually achieve the outcomes we want from those things.
Yeah, I'm going to talk a bit about the PAS 2035 process for those who aren't familiar with it. I'm going to talk a bit about our work on community buildings and a bit about scale and NESFIT and how we drive that. I run an architectural practice in Aberdeen. There's 5 of us in the practice at the moment, and we use all the kind of technical equipment and methods available to us to assess buildings properly and do retrofit wherever possible. And 99% of our work is retrofit. I'd say probably about 60% of it is domestic, and the rest you're about to see. The PAS 2035 process is, it is clunky, and we've heard some great comments about it this morning already. I've been a retrofit coordinator for 2 years now, and we haven't actually delivered any PAS 2035 projects certified, partly because we didn't have to, but also because there are sort of limitations in it. But what I would say is that fundamentally it's a good process, and I show this to all our clients, and I think they appreciate it. They want to be taken through that process. I guess just to talk about the highlights for me is that introduction. Understanding people's motivations for what they really want to do is such a useful conversation. You're getting to know them. You're getting to understand their tolerances for disruption and cost and all these sorts of things. And it's amazing what we do here. I mean, there are people who are very motivated by the climate. They want to get on a heat pump as soon as possible in a drafty granite property in the middle of nowhere. You have to break it to them gently. But, and other people are just motivated by cost, and actually 90% of our clients are just cold. They want to be warmer. So do a good house survey, do a good assessment of the energy. We use the passive house methodology for all our projects. Evaluate all the options and come up with a plan. And when you come up with a plan, sit down again with the client and say, right, this is the reality of where this building is. We have the worst building stock in Europe for energy efficiency. This is going to be painful, but let's make a plan. And totally agree with some of the previous speakers who've said that. It's if we're going to get to net zero, we need a plan. So let's do that. Coming up with a retrofit design, doing the installation, using good contractors who you get along with and you can have good conversation with, good dialogue is really important. And PAS 2035 does insist that monitoring is the most important stage of the whole process. And I think that's really important to emphasize, because actually that engenders a huge amount of trust with your clients when you're talking about this. And retrofit is entirely about trust. People are tired of being sold things for energy efficiency. They really like the idea of having someone independent, a retrofit coordinator, to walk them through the process and say, this is good, this is bad, and so on. Lots of our clients have had 30-page reports from Home Energy Scotland and then have said, go away and get 3 quotes. No, people need more support from experts.
What if the climate transition and retrofit of our homes and streets were designed, owned and governed by the people who live there? That leads to an awful lot of questions, which many of the previous speakers have spoken about already. What I'm going to talk about in my slot is, do you like the graphics there? You see that? What if the advice service for the retrofit of our homes and streets were designed and governed by the people who live there? So Local Home is trying to do that. Since 2021, when we incorporated as a KIC and as a co-op, and at the moment we have 170 members of the co-op, and they provide the governance for the organisation, setting its direction and its policies in terms of what the staff, like me, so employees like me, can do, and what we can't do in terms of what's good practice, what's ethically and financially and morally prudent in the interest of Glasgow's homeowners and the housing stock in the long term. And so we provide an advice service, which I'll speak about a bit later, and we also participate in innovation, because the retrofits, because this is all about, for us, we're focused on private homeowners, so owner-occupiers, and especially the able to pay. So there's fantastic stuff going on in social housing, but there's really not a lot going on in the able to pay sector. And when you think about climate justice, it's really the people in the warmest, biggest, most comfortable homes who are creating the biggest impact on the climate change. And really it should be they who are encouraged, obliged, and perhaps helped to move first in terms of decarbonisation, while the sector is still emerging and there's lots of risks still to be ironed out. So we're in some innovation projects, which I probably don't have time to speak about, but we might touch on them in questions. So just briefly, what's the need for a community-led advice service? Well, in the broadest terms, every home has to be changed. 2.7 million homes in Scotland and thousands more to be built in the next few years need to be retrofitted for net zero, and they need to be done extremely quickly. It's too difficult for homeowners, as people have said themselves. The Home Energy Scotland service is great, but it's not enough. And the full service past 2035 thing is just out of reach for most people. But there's a fantastic amount of civic capacity amongst people that want to do something. They just need some appropriate help. So we're really trying to provide some consumer protection, hand-holding, helping people to avoid regrets. It's really about avoiding regrets. So it needs to be trustworthy. And that picture there, by the way, is the Each Home Counts report, which tells us what can go wrong and what we need to do to avoid things going wrong, which is, for us, the key things are advice should be free of conflicts of interest, in the interest of the client, and it should be risk managed. And it should, as Bill was saying so emphatically early on, it should be led by the circumstances and conditions of the homeowners.
But I think the main takeaway for today is to try and think of traditional buildings as opposed to historic buildings. I'm from a historic environment, Scotland, but actually what we're interested in is the technical makeup of older buildings and having technically appropriate solutions and interventions. In Scotland, the numbers are quite big. 20% of Scotland's buildings are traditionally constructed. If you go into some older historic, settlements, city centres, it's perhaps much higher too. So there's big numbers here, and I would argue if we get it right technically, we get the right aesthetic outcomes as well. Retrofit approaches then what I'm going to call conservation retrofit, which hopefully picks up a little bit of what Bill said. An example, I will apologise in advance if some of you have seen these slides before. I've chucked in a few extra ones as bonus tracks, so to speak. I'm quite big on counting the carbon. I would posit that our problems are resource problems, the way that humanity has been mashing through the planet's resources, aided by that liquid gushy stuff that comes out of the ground that basically gave us a free lift on all sorts of odd things, with the consequences that we now know about. And actually, one of my overriding things is not that energy is expensive now, is that it was actually much more expensive historically, and they were much more canny with how they used energy in different ways. So I think we've got quite a lot to learn from our predecessors. A bit of carbon maths, and that's kind of work in progress, but I want to introduce the idea of, at the heart of this is how much carbon do we chomp through in the interventions we make and the policies and decisions we want to apply to the built environment. And I think the built environment is a bit of a whipping boy for other activity. If we want to fly abroad twice a year, the transport lobby will lobby for more carbon emissions in their bit and say, housing, you come up with more savings. So, where are our priorities? So I don't think housing should take every single hit. We live in houses. That's our well-being centre, that's our shelter, that's a massive part of our lives, and I would suggest that we prioritise that over other things. And if we can't get carbon perfect in housing, maybe we accept that and do a little bit less carbon on the motorways and the aeroplanes and all the other stuff and the 1.5 cars that everyone has, or what have you. So just a big pitch on written HES material. We've been writing and publishing. Sandy Halliday was very active with us from 2008 earlier. So we've written about a lot of this stuff. I know it's not the best way of learning information now, but please have a look. And a quick summary. So let's just bash into it. Okay, we were talking about the demolition of social housing. This is me watching the demolition of some 1930s era housing in Edinburgh, Craigmillar. There wasn't actually technically very much wrong with those buildings. I would suggest they were quite well proportioned, quite a lot of light. They weren't that well insulated, but hey, we can fix that. Yet the whole area was kind of... So the people, the district, the people, the architect was blamed for other failings. And I think it's very easy because bricks and stone can't respond. And I would argue in terms of resource retention, I don't think that's a very good story. So that's kind of where I'm coming from. As a child, I was cursed to be brought up in the 70s. All I saw was demolition. And all I saw was, those houses look all right. Well, why are they knocking that down? And that's as a 7-year-old. So, I've been noticing this stuff for a while, which is sometimes a curse. I coined this term a few years ago, carbon crime scene, for so-called retrofit. I didn't get round to working out the carbon mass for that, but I still think it's a moniker that is deserving of application in some circumstances. And I think the bigger philosophy of this, perhaps we can pick up this afternoon in the Socratic dialogue. So I'll just hit you with some sort of technical stuff now, but otherwise I'll wibble on for too long. Even the materials we put into the buildings to save energy have a long carbon tail, and some of those tails go on for longer depending on how that material sits, the off-gas, the other stories that go with it. So I think we need to be cognizant of that.
It seems though retrofit is a major buzzword, is at the heart of a lot of discussions. There still continues to be a major attitudinal problem when it comes to big institutional property development. We just see it in Glasgow right now with some of the biggest proposals forthcoming about mass demolition. So we've got Buchanan Galleries, we've got the St Enoch Centre, for example. Is this the best way forward? There's a lot of buildings that are probably quite easily adaptable. What do we need to do to change building regulations to make looser fit adaptations easier to achieve? So we've got over 400 redundant office buildings in Glasgow city centre. I think the combined office space, or combined empty commercial floor space in Glasgow, is equivalent to the space inside the Empire State Building in New York. So it's a vast latent opportunity for this city. And also we have in Glasgow the lowest residential city centre population in the UK of any major British cities. I think it's around 20,000 compared to Manchester, which has about 48,000 people living in the city centre, and they've doubled that in the last decade and are going to double it again in the next decade, and we're talking about just getting to around 40,000 by the mid-2030s. So the rate in which Glasgow's changing its situation isn't good enough, and I don't think we have the institutional capacity to do much about it.
Very excited to introduce the Socratic Dialogue, and I'm very excited to facilitate this today. And as Sandy said, I'm not a architect or an engineer. I come from a very different background, so I'm very excited to kind of see the responses that we get to the dialogue. So a Socratic dialogue is a method of philosophical inquiry that engages in an almost conversational approach with others to explore typically complex ideas and concepts. The call is to reach a deeper understanding of a topic through dialectical discussion. So this is a dialogue, it's not a debate. We are not here to kind of change each other's minds. We are here to kind of get to the root of everybody's thinking and to get an understanding of what lies beneath an issue. This is a process that requires discipline and active participation from both the panel and the audience. So we are going to create a free and a safe space for all the participants to share their thoughts to the question, to make or to mend. That is the question. So, open and informative questions. Why, what, who, where, when, and how? Why do you think that? What do you mean by that? What did you do then? We will not be allowing any judgmental questions. We will not allow for any steering. So when you kind of want to ask your questions, you kind of can't give quite a long paragraph. You have to kind of go straight in. And we also are not going to allow for any closed questions, do, can, or are, or questions that require a yes or no answer. When does the dialogue end? When I kind of first started doing dialogues, the moderators kind of said, the dialogue ends when we all die. Luckily enough, it's going to end when today's session ends, I think, when we all get a bit bored. But what I would kind of maybe like you to all think about is what you feel the essence of the dialogue was, so kind of what you feel the responses are, or kind of if you felt that the Socratic dialogue was a bit crap.
So I think unless we collectively understand where we want to go, we can all be right. So understanding the outcomes that we're trying to achieve is essential. So in this question, what are we trying to do by retrofitting or demolishing? Is it about embodied carbon? Is it about saving buildings? Or is it about trying to strengthen society? So just because we retrofit something doesn't mean the outcomes for the people that use it are good, better, improved.
Regeneration through demolition and replacement is a huge lack of imagination. If you're an architect and you look at a building that's already standing up, you've got all your constraints. We as human beings are more imaginative when we have constraints to work within. So that's something that we aren't really talking about. We've got this, we've pretty much solved the technical side. We know what we're doing in many, many cases.
Obviously, I don't think you always retain buildings, but there are so many reasons that people find to get rid of them, which are spurious in my opinion. Scale, we have no choice but to engage with retrofit, so we might as well do it well. I think we all know that. I think that's no longer the elephant in the room that it's been for so long. I'm pretty sure we're all comfortable with that. The other thing is that refurbishment is fundamentally cheaper than demolition and rebuild because most of the stuff's already there.
I believe statistics are difficult to find. I believe the majority of construction waste actually comes from the waste arising from new buildings and the process of refurbishing, altering and extending existing buildings. The latter often led by changing uses, fashion and consumerism rather than an improvement in environmental performance or a change of use to domestic. We must ask, what does this do to sustain?
And I think also a wider view of retrofit will free us from what I've called material capture, where essentially you have a very limited range of manufacturers imposing quite a narrow set of options on us, and changing that dynamic, changing the habits of those designing retrofit with such a limited material palette is actually very difficult. And you try suggesting something new to the construction industry. Good luck with that.
We're still paying VAT on listed buildings. I think this is almost a criminal act, and certainly anti-conservation and anti-environmental. So how do we get out of that? Well, we left Europe in 2016, so we could obviously reform the whole thing immediately, except that, as Paul said, the revenue flow would be lost. So we've lost a lot of tobacco duty revenue flow. We're about to lose a lot of petrol and diesel revenue flow, and losing the revenue flow on existing buildings paying VAT would be a bit tough.
Interestingly, existing buildings are quite sophisticated. There are things to learn in all of these. There are lots of things which are not immediately obvious. And that's something eventually you learn to start looking for things and understanding. And maybe understanding is what's missing from this question.
But my question is, what changes would you make to the community right to buy legislation, and how would you support co-housing alternatives to the current, or some of the current ownership models?
I think in terms of the community right to buy, it has to go to the community gets first. Not just like they get first say, but they don't, it's not off the value of perspective. It's not off the value of what someone else could get, what someone else could cram onto it, what some developer can build terrible student housing onto a land bank. So we need to understand that lots of these communities don't have the resources, and severely deprived areas, there aren't resources.
How do you think we can break the immense lobbying power of the construction industry to stop them vetoing any VAT reform? Because I suspect that might be where it's coming from. Do you have any views on that?
Well, I think you've got it in one. I mean, political contributions to parties by people like Berkeley Homes and so on are skewing the political philosophy to the point of corruption.
A lot of constraints can fire creativity, and I'd like to see that going through education. I'd like to see that going through the profession. I'd like to have people say, okay, this is what it is now, but it's not what it can be. And that's maybe something with heritage buildings. When you see the ones that have survived over a long period of time are not necessarily single-use buildings. They have changed many times. So if you can look at things and see opportunities and see what's possible, then actually you can convert far more things to housing. You can convert far more things to... Currently we've got a couple of projects going through the office which are taking old department stores and turning them into something else without knocking them down. So we're creating a health centre in one, we're creating an archive for a city and a public facility in another. And you look at that and go, well, we can keep doing that. You know, it's quite an easy thing to do because you've already got the hard bits, which is the foundations, the shell of the building and the services. So the inside bit's actually one of the easier bits.
I would like to thank the panel, but also the audience for their participation today. I know it might have been slightly frustrating maybe for having to word your questions in such a specific manner, or potentially not being able to speak when you would like. So kind of thank you for kind of joining in and listening and not walking out.
It's kind of what you'd expect from a one-bed kind of tenement flat, hall in the middle, big kitchen in the back. 1901 sandstone, blonde sandstone, big high ceilings, so almost 4-meter ceilings, 2.8-meter tall windows, which make them unbelievably expensive to replace, and all kind of the standard things that you would expect. The flat hadn't largely been touched since about the 70s. It was absolutely kind of lethal, boiler and electrics, all surveyed end of life, 800 mil thick walls, suspended timber floor, kind of, you know, a bit bog standard what you would get in Shollins that hadn't been renovated yet. So I set very specific objectives for my retrofit. which was to use breathable construction to protect all the original masonry and timbers. Primarily, my focus was improving comfort. So, as Jonathan said, I'm an architect and an engineer. My second degree is actually in building physics. And so one thing you kind of learn when you study building physics is that we design to remove discomfort. So basically, comfort is the absence of discomfort.
This is the ground workers putting in the glae pour. This is the over the top of that, the slab going in place. This is Thomas, who didn't really understand what the glae pour, didn't really like the glae pour, couldn't use the compactor on it. It just went everywhere. We phoned Hempcrete, and we phoned UK Hempcrete, and they said, try doing it with a piece of plywood on top of it. It's sometimes you're just sort of wondering about exactly how you're supposed to do these things. Slabs in, but slabs in, herein is the biggest mistake I made. Knowing that the roof needed to be on site, it'd already been waiting 2 or 3 weeks in their studio, in their workshop. I chose not to put the external drainage in and got the scaffolding up for the roof instead. The roof went in, and it was a lovely day. Looked great. You started to feel the spaces and what it's actually going to be like, and thought, okay, I'm getting somewhere. The Hempcreters arrived quickly on their heels. This is them putting Wattstop on to stop some of the ground raises behind the building, so this is just to sort of resist some of that moisture. And then quickly afterward, the Hempcrete itself, you can see them batching out here and the casting going on. You also see in that moment, we've had to put up all the internal timbers around their working. So the Wattstop goes on, then the timbers, then the Hempcrete. So we're trying to sort of juggle them on site.
I work for a company called Snug. We have built, I'll show you a link later so you can see for yourself. I'm not going to talk about the product, but we live in this, we sort of work in this space of trying to help people actually understand what they need to do for their homes, and then work out what grants are available and bank financing options to actually finance that improvement in parallel with finding someone to actually do the work. So that's the kind of the solution that we offer. Just a bit of a context. The landscape on the left there, I probably don't need to explain to the people in this room. You'd be familiar with the fact that heating of residential homes is a significant contributor to the UK's carbon emissions. Various different numbers. We've gone with 21%. I've seen various different versions of that number. And then the chart on the right you might also be familiar with. This is from the Climate Change Committee, which said a few years ago now that the cost of retrofitting the UK's homes to the level that we need them to be to achieve net zero by 2050 is approximately £250 billion. I've seen estimates of double that and slightly less than that, but again, that's the number that we typically go with. And that's going to be a huge challenge. It's obvious, certainly under the current government, but even under future UK governments and obviously separate arrangements in Scotland, it's obvious that grants aren't going to be put in place to finance this kind of transition. There is going to be a huge dependence on individuals paying for these improvements for themselves, but the reality being that not everybody has money kicking around for this sort of thing when there are other priorities, other things people want to do with their spare cash, and therefore financial services have a huge role to play in terms of financing these improvements.
Although I'm a chartered building surveyor, I don't always admit it, and I didn't admit it when I inquired about getting some help for retrofitting my house in Orkney. And so I'm just going to tell you about what happened during that process. The first stage was to get an energy assessment by Home Energy Scotland. I could give a talk about what happened then, but I don't have time to do that. I'll tell you something about my house. It's on a village street. It's sandstone, 1860s, pointed with cement. Got various problems. You can see the splashing water up from the pavement, plastic windows, some of them seas shut because of the marine environment, no trickle vents, and a problem of damp getting through at the junction between the stone and the plastic. At the left, there's an old shop with a very drafty door and a single glazed window. The day of the technical survey arrived, and I expected some sort of retrofit assessor or someone like that to turn up. And what happened, there's a local building company who are a very reputable company who do good work, have got the contract to do the actual internal wall insulation. And the guy who turned up to do the technical survey was very friendly, but when I spoke to him and looked at his LinkedIn profile, it turned out that his career up till then had been in the sheet piling industry, that he'd come up to work on the new pier in Stromness and liked Orkney so much that he'd got the job of a contract manager with the building firm. And he'd worked for them for 6 months, and he was doing the technical assessment on my house. So far, the people I dealt with at Warmworks and the technical guy knew nothing about retrofit, which didn't inspire me with confidence.
Thank you. We've been looking at these very good submissions. Very, very impressive. All 5 of them are very, very impressive. I've had the chance to look at the schemes in detail over the last 2 weeks. It seemed to me that they could fall into 2 classes. There's what I would call the detailed building design. That's the Parisian schemes, the St Andrew's Library and the Loch Winner, where we have a very clear architectural end result. The other 2, the homeless housing in Aberdeen and the Bowness Library, have developed a lot of very, very interesting ideas, and the kind of commitment in Aberdeen to doing something about the homeless situation is very impressive. Rona Bissett's scheme for Paris should get the overall prize.
I would just like to say thank you so much, everybody. I was here yesterday and today. It's just been a great experience. I didn't really mind about running, but I got told about SEDA last semester, and I kind of feel like I found my path in architecture school, and being able to look at more sustainable designs, and also how my peers have found SEDA, and how they've also looked into sustainability and ecological designs. I feel like it's really helped my course and everybody else, so I'm really thankful for everybody today and for Jim. Yeah, thank you.
I get the first person who would like to share their project then. At the back, gentleman at the back, please.
We're in the process of renovating it. It's in 2 halves, this building. It's a 19th century, 3/4 of it's 19th century building, 600 thick walls. The other third is built in the 1930s with a cavity wall. Externally, it's coated in cement render. We've tried taking a bit of the render off to see what the stone light was underneath, but it pulled the wall apart, so it's a very strong mix. So I think realistically we've got to keep the external render on.
At the moment I'm working on my own house in Dundee, which is a 1973 ex-council home. Excellently good construction, cavity walls, moisture problems, that sort of thing.
It is a ground floor Victorian 1860s tenement flat with a early 2000s extension on the back, which actually feels like it's the main problem.
So we are doubling the size, and it's a matter of where we choose to do what type of installation, if it's north-facing, south-facing, so where we build extension is taken into consideration the cost, VAT, a lot of considerations on a very simple cottage. I've got the plan, it's all, and I've already done sort of the design, but I'd be interested in having it peer reviewed by people who know a lot more than me.
The particular aspect of it that I'd like to discuss is the internal insulation of the external walls, whether some of the wall linings can be retained or not.
I would like to talk to people about 1918 Category B listed naval barracks called Port Edgar at South Queensferry, just under the Queensferry crossing, which I'm currently working on a retrofit of to 49 homes for Lara Housing Trust.
This is how you approach a building like this, what you have to consider, and once you've got that information, what's possible potentially to do here?
It's my flat that I was trying to discuss, and it's a colony upper flat in Edinburgh, and it needs a bit of maintenance and probably retrofit as well, and don't know where to start exactly, plenty of ideas and so on, so I was hoping to maybe get some guidance.
We've got kind of two membranes there, and then plasterboard on that.
It would be lovely, yes.
Yeah, the house that Tom did, which was inside.
That's right. Anyway, it makes the existing building fabric colder, and even the stuff you don't insulate, I mean...
That's right. That floor is a single story open plan with a sliding door, so it's quite open space.
I would guess there might be a problem with overheating in summer, but in winter,
Make more financial use, a financial benefit from the rooms that you've got without actually having to change too much.
It's horses for courses or whatever, and everyone has to make their own mind up in their own circumstances.